Hi there, this is Dr. John, your physics and math professor, and today we're coming to you with another transformations videos. Remember we said that there was 3 different types of transformations: stretches, reflections. Stretches could be stretches or squeezes, both are used with the same word here. Reflections and translations. And the word translations, a little bit unusual. We talked about that in another video. The idea is that if you go in a subway or in a bus, you get yourself in a bus, you go from one location to another, you're translated. That's another valid use of the English word. You're translated from one place to another, but your shape stays the same. So in this case, translations would have the shape staying the same, but they're moving up, down, or right and left. So here we have what's called a vertical translation. That is like in basketball, where you're shooting a basketball and you have a vertical, that means you can jump high. So they move up and down. So here we take our y is equal to sine x, and we're going to add to it. What that means is whatever the y value is when we get sine x here, whatever this y value is here, that's this whole thing, sine x, we're going to add 2 to that. So here we have a basic sine function in the purple here, and we're actually taking the whole thing and raising it up. We're raising it up vertically by a factor of 2. So we lift it up in that way. So this is just simply like that. We find the y value, just take that function, add 2 to it. That's very simple. And of course, if you made this a minus 2, you take the whole thing, the blue one would be shifted down by 2. So we touched on this last time. We also said that you can write it this way, y is equal to sine x plus 2, just like this. Or you can take this 2 to this side and associate it with the y. So it's y minus 2 is equal to sine x. That's another way of writing it. We're going to be using this now when we do our horizontal translations. So over here, I've written out for you a very, very basic horizontal translation. Horizontal means here's the horizon. Like if you would look out and you would see the horizon, then this would be, you would move it along the horizon, keeping the shape the same. So here's in the dotted purple, I've created y is equal to x squared. And then over here, I've done the same thing. I've just shifted the whole thing over by 2. So this is 0 here. The x value is 0. X value is 1. X value is 2. So notice the origin here, or the axis of symmetry for the purple one is 0. The axis of symmetry for the blue one is 2. So I've shifted the whole thing over by 2. Let's see how that works out with our numbers. So I've put a couple of numbers in here for x and for y. This is y is equal to x squared here. So I've just written x squared here. So if x is 0, y is 0, x squared is 0. If x is 1 or minus 1, you square that and you still get a 1, just like that. So that's these values right here. And if x is 2, y is going to be equal to 4. Of course, if x is minus 2, it's going to be 4 as well. That's these values up somewhere up here. 2 and 4. So that's the original function. I'm just going to erase this so we don't get so crowded. I don't need this. We could do an infinite number of points. I've just picked a couple of easy to use points. So let's say I wanted to shift the whole thing over by 2. And I'm trying to figure out how would I describe it? I've written this in here because that's how we're going to describe it, which is analogous to this here. Notice we had a shift to the up in the y-axis by 2. Here, this looks like a shift to the right by 2, but let's check it out. Let's see how it works. So what we want is we want the y values here to be the same. So here we want the y values to still be 1. We want that to stay being 1. So if the y value is 1, we want that to stay being 1. What do we need to put in for the x value? Just think about it for a second. Previously, we had to put 1 in because 1 squared is 1. But now we want everything inside the bracket here to be equal to 1 so that 1 squared can be equal to 1. So that's going to have to be 2 bigger. The x is going to have to be 2 bigger than it was before. So instead of 1, we're going to have to make this a 3. So we're taking whatever x value we have here and we're adding 2. But we're keeping the y value the same. Same here for 0. If we want this to be 0, inside here this has to be 0. So if everything inside here is going to be equal to 0, then this has to be equal to 2. Because 2 minus 2 is 0. 0 squared is 0. So this is going to have to be equal to 2. And then over here, of course, we're going to want this here to be the same as this. So remember what we did to this one? We added 2 to the x value. So let's add 2 to the x value here. So let's check it out. 1 in here. 1 minus 2 is minus 1. Minus 1 squared is also equal to 1. So that's just like here. So that's the same y value. And over here we have the y value of 4. We want to have the y value of 4, so what do we need to put in here? We're going to need to make everything inside the brackets here equal to 2. That means this is going to have to be equal to 4. 4 minus 2 is 2, 2 squared is 4. So notice in each case, the y values stay the same, but what we did is we added 2 to the x value. And we put this is sort of analogous to this here. This is a shift upward by 2. It looks like it's a shift downward, but what we really mean here is we have to make the y bigger so that this here becomes the same value. This still becomes the same value. Same over here. We're going to need to make the x bigger so that x minus 2 is the same value as it would be over here if we want the same value for y. So I hope this helped to illustrate a horizontal translation. I'm just going to erase this here and sketch a couple more for you really quickly, just so you can see a couple of more, and then we're going to go on. Give me 2 seconds. So here I've got a couple of more functions that I drew up for you. Here's the absolute value function. Y is equal to the absolute value of x. So whatever value x is, if x is 1, y is 1. If x is 2, y is 2. If x is minus 1, take the absolute value, y is still 1. So that's why we get this sharp edge here. Now what if we wanted to draw the same function here, but we want the absolute value of x minus 1? Remember we've talked about if we associate it directly with the x, a shift to the right or the left, what we have to do is we have to make the x bigger to make this work. So it's going to be something like this. I'm going to show you and then I'm going to demonstrate mathematically. So it's going to be something like this here. This would be the blue one over here. So let's take a look at this by making a little bit of a chart. Here's the original values, 0, 0, and then 1, 1, and then minus 1, 1. Now what are we going to do here? Well, for every value here, we want to keep the y the same. So the y value here is still 0, but the x value increases by 1. So I put a 1 in there. And then this one over here, the y value stays the same, and the x value increases by 1, like that. Similarly over here, the x value stays the same, the y value increases by 1 to make that 0. Let's take a look at our diagram to see if that's what we did here. Change colors on you. So this 0, 0 here goes to this point right there, which is 1, 0. The x value is 1. This value right here, which is minus 1, 1, minus 1, 1, goes to this point right here, which is 0, 1. So this works. So notice here, we took this, we wanted to shift to the right, so we put x minus 1, we put that in there. Here we sort of did this mathematically. I'm going to do another one at the end of this video mathematically that's a little bit more complicated. So let's take a look at this one over here. I have this one, and I'm taking this, I'm adding 2, which means I'm going to need to reduce x every time to get the same y values. Remember, we want the same y values. We want y shifting over like this. We want this to be a horizontal shift, so we don't want the y to change. That means we're going to have to decrease x. So in this case, 1, 2, minus 2. This is where this is going to start, and it's going to look something like this. It's pretty easy to sketch some of these, some of the basic ones that don't have an odd shape. You can sketch them pretty quickly. And I'm going to do one for you that we're going to try to sketch, and then we're going to do mathematically. There's mathematical ways to do this. I've illustrated this here, but I'm going to do this for you with a little bit more complicated one. Let me draw that up. Give me 2 seconds. All right, we have a function that I've written up for you here. Notice there's a minus 4 directly associated with the x, and then there's this minus 3 on the outside. So we would find whatever function that is and then move the whole thing down. So this is a vertical down by 3. We could put this over here and make this y plus 3, make it just similar to this, but this is the standard way of writing it. So this is going to be a horizontal shift to the right, because we need to make x bigger, and then we're going to push everything down. If this was over here, this would be a y plus 3, like this. This would be a y plus 3. So we need to make y smaller, but you can also see this directly over here. You're going to have to make whatever the value you find for y, make it smaller. So let's do this in 2 pieces. We're going to do this piece first. The x and the y shifts or translations. We like to use translations because we want to keep SRT, sort. We want to keep that order, and we don't want to use another S word here. So we use the unusual word translation. So we want to do a translation. These are independent. The x and the y translations, you can do them independently of each other. So the x translation is going to be 1, 2, 3, 4 this way. It's going to be something like this. And then this one is going to be down by 3. I'll use another color for that. Here, 1, 2, 3. Let's move across here like this. The origin would be there. and it's going to have the same shape. Remember, when we translate, we're in a bus, we're in a subway, we don't change our shape. We just translate it from one place to another. This shape stays the same here or here. So the final thing is going to be something like that. So now to do this mathematically, we're going to look at the original. Always look at the original, which is the one that doesn't have any modifications, doesn't have any stretches, translations, reflections, doesn't have anything. It's just the base function. We're going to look at that, find some specific points that we might find useful. So here we have, in this case, we don't have a lot of sharp corners or anything. We have this corner, and then we're just going to have to find some points that are easy to use, that have nice numeric, nice even numbers, nice whole numbers. So obviously we can use 0, 0. So this is the original points here, 0, 0, this one right here, 0, 0. And then 1, 1 is on there as well. 1, 1 is on the original, so I can go 1, 1, like that. And then another one here would be if we had x equals 4, 1, 2, 3, 4 right here. What is y? It's the original one. It would be the square root here, which would be 2. So this one here would be x value of 4, y value of 2. I'm not looking at this one, I'm looking at the original one here, the purple one. So let me just draw the original one in here. This purple one here, just like here, the root of x. That's the original values here, and I'm going to give you at least one more value. Remember, if the curve is smooth like this, if it's an unusual shape, you may have to have a number of different points, but if it's smooth like this, you know the shape. Once you have 3 or 4 points, you're going to be able to sketch out the curve because it's going to have exactly the same shape if it's a translation, if it's only a translation. Of course, if it's a stretch or a squeeze or a reflection, it's going to look a little bit different, but the shape is still going to be the same. So here's 3 of our original points. Now, what is it that we're going to need to do to them? Well, for one, we're going to need to do what I did here with the green one, and that is take the x value, x plus 4. And then we're going to have to take the y value and subtract 3. So I'll take the y value and subtract 3. So let's write these all in here using my color code. So I'll take the x values. This is 4, this is 5, this is 8. Just taking this here. And then the red ones here, I'll take the y value and subtract 3. So this is minus 3. This one's minus 2. And this one is minus 1. Notice these are all negative. Sort of look like the curve over here was negative. But we're going to draw a new curve underneath that just so we can compare them. So I've drawn myself up a new xy axis here with labels up to x equals 8 because we're going to need that. And then the y down to minus 3, just like this. So let's take these points and just plug them on here. So first point we're going to have is 4 minus 3. So that's 4. I'll make little dots going down like that. So that's a point right there. And the second point is going to be 5 minus 2. 5 minus 2 right there. And then 8 minus 1. 8 minus 1 would be sort of covering over my 8 there. Excuse me for that. So notice these 2 points here would be these 2 original points right here. And this point here would be this point here. Maybe I've stretched this out a little bit. I've squeezed this a little bit from this, so it might not look exactly the same. But now here we would have our final shape. We start here. We just sort of fill this in. Yeah, as we continue on, it's going to go past the axis. Notice this shape, very similar to what we did here for our rough shape, but this one is created much more mathematical because we actually had some specific points that we could put in here. Here we just sort of guessed what our first point was and then just went on and sketched it. Here we found a couple of specific points and then matched a sketch to it based upon the shape of the original. So I hope that helped. In the next videos, we're going to start going into stretches and squeezes and reflections, which I think is going to be really important for you. So like and subscribe, come back for the next video, and I will see you there. Bye-bye.